Hi, I'm Carolyn Mason, and I did a case study in the recognition and emotion of images. For this project, I focused on finding angry, happy, sad, and neutral faces in a set of images. My main hope for this project was to take a big set of images and very quickly pick out faces for whatever use or intention the user had, but just to increase the speed. The software I used, I wrote this all in Python, and I used Keras, and I used a convolutional neural network. The dataset that I used was an FER plus dataset. I downloaded it from Kaggle. It was used for a competition a few years ago. Overall, there are 28,700 pictures, and they're framed faces showing emotion. You can see a screen capture of some of the pictures down here. They're all in grayscale, 48 by 48 pixels. This big data set included angry, disgust, fear, happy, sad, surprise, and neutral. I cut it down just for the scope of this project, and then you can see what the document actually looks like, where there's a label and then the image. An overview of the steps. I downloaded the data from Kaggle. I set up a test and train set from the data. I built the convolutional neural network, and I iterated until I was happy with the model results, and then I ran it on my own images. Now I'll give you a quick overview of the code. I downloaded the data from Kaggle, and as I said, I created a light version. So I only took I pulled out the data that I wanted, and these were the original labels for each of those, and I fixed the values so that way when I was using one hot encoding it wouldn't have a 6 and not know where to put it, and then I just resaved this CSV into a light CSV. Then I re-imported that CSV and set up my data sets. So I created a train data with my train labels and test data with my test labels. And I iterated over every line of the CSV, and I split it up so I changed that number so that 60% of the data was in the train data set and 40% was in the test. I also normalized the data set and just appended each set. After this, I put the labels in one hot encoding and just set up the data to go into the neural network, making sure it was all sized properly. Next, I built the CNN. The main pieces here are how it's set up. So the input shape that's expected is a 48 by 48 grayscale image. So I started out, I created several different convolutional 2D images followed by max pooling, and that is going around the image and taking little snapshots of everything, just making sure that everything piece is covered. I created several layers here. I was having an issue with overfitting, so I ended up including some dropout layers. I have 1, 2, 3 dropout layers, and that improved the model. Another test that I did was I tested out different levels of L2 regularization with different lambda values, and I found including the regularization helped. What value I used, not as much, but I was able to improve overfitting. And then finally, in my last dense layer, I will output the number of classes, and that will just say, okay, I'm choosing one of my emotions, and I will tell you what it is. Finally, I ran the model. I created a function that was just create and run, and then I could input, these are just my different L2 lambda values, and then in that model I ran the model several times just to get the results, and then I plotted them up. So when I ran these on my own images, I loaded that model, and then here's my emotion table. So anything with 0 is really angry, and then happy, sad, and neutral. And I just, for my own sake, documented how many images I had in each category. And here are the results I found. The model had a final accuracy of 66.5% in predicting the 4 emotions. The biggest point of concern I had was overfitting. You can see that the validation accuracy is below the training accuracy. This should be able to be improved, but it was difficult given the nature of the data set. And I'll go into that a little bit later. And then here's my training loss. You can see again that it doesn't quite line up. One might expect this to line up better given how much data there was, but we'll continue on there. Here I'll run a small demonstration. You can just go ahead and see the examples. I just took a set of 20 pictures on my own computer and put them through. So a lot of these are my own images that it was not trained on, and you can see angry. I spit out the name of the image just so you know where it came from, and then what percentage it sees of each type of face. So angry did pretty well. It got 4 out of 5. For some reason I thought this, the fourth one down, was happy. And then happy did really well. It got a 5 out of 5. Neutral did okay. Again, it got 4 out of 5. This was neutral. This one did not capture a face, so I'd have to do more considerations there as to why it didn't see a face. Sad did very poorly. A lot of the times it did not capture a face, but it did get one image. I'll go ahead and do a quick demonstration. So here's the original data set just for observation, and here are the images on my computer. These were the same ones we saw in the PowerPoint. So, and I'm going to go in here. Here's the code. I showed you a quick snapshot of this earlier where we're loading the model, taking the labels, and then all I'm doing is taking a path to where my pictures are and then sorting them to put them in the right order, and then reading them in, resizing them, because the model is expecting a certain shape. And then I'm processing the images, and I'm only taking the ones that have a decent match. A lot of them don't, and that's where I'm printing that there was no face and would need to go back and look at it. And then all I'm doing is everything's one hot encoded, so I'm translating what the output value is back to something we recognize using this dictionary. So I'll go ahead and run this. And again, this is just reading in all the pictures from this folder. You can put them next to each other to compare. And this is the same thing that I copied into the PowerPoint. So this will show an angry image, and it is showing that it isn't indeed angry, so angry 0 report compares to this one. And then just going down, angry, angry, happy, neutral, and then sad. So sad 1, it decided that there was no face. And this is the original set. The set that was actually used were all input as the same size, so there was no variability there. Okay. So then what I did is I wanted to know, I did some further investigation as to why the sad images did not seem to be coming out as well, if it was just that set that I had, maybe the faces were cropped poorly, or there was some issue with the model. So I took my entire data set that was from Kaggle. I took the images that it trained on and the images that it was meant to test on, and I just wanted to see if I throw these all in there, what percentage do I actually get back? And so I did this for each one. I did angry, happy, sad, neutral. Angry got 27%, happy was 82%, sad was as low as 10%, neutral was 49%. So you can see there's a huge difference between how each expression did. I don't know if this is because sad images have more in common with other ones, like their eyes could be very similar to neutral. That neutral face looks really similar to this unhappy face, where when you're smiling you've got a bigger deflection and you can often see teeth or happy eyes. I think there's also a bigger range of how the sad images are portrayed. There are more hands that could be covering the face in despair or crying, or eyes open or closed. I think that would be why the sad images are having a harder time, and this definitely needs to be addressed in future runs, because the whole average would be increased greatly. Rather, the sad image is not a good result, and needs to be improved. So what I've learned, this model has an accuracy of 66.5% for all the emotions. This is reasonable. The top reference from Kaggle for the competition for the set of 7 emotions is 71%. So there's definitely room for improvement, and there's definitely room for improvement for the different emotions. And this project taught me how to train the model with categorical data and what knobs you can use to help improve overfitting. This includes L2 dropout regularization and then dropout as well. The key lesson learned is addressing data and improving the results from categories that did not perform well as others. I'll just quickly, go through and show the other knobs that I tried out to improve the model. This is in here. So other knobs that I tried out. So here's a summary of my model, and you can see all the sizes that it's expecting all the way down. And the knobs that I tried out to avoid overfitting, as I said, were L2 regularization and dropout. I tried using data augmentation and label weights and did not have any luck with that. I think the data set was big enough. You can also use k-fold for testing the model. Time to run the model. I did play around with a number of epochs. I found that 15 was good enough. Image size and shape, I was given a standard image size. You can also change learning rates and the type of optimizer. I found that Atom works just as good or as well, better than the other ones. And then finally, for accuracy, you can use a pre-trained model. This could be a good idea in the future, but I decided just to stick with one model for this set. And then you can use different dense layer activation functions, none, sigmoid, reloy, or tan H. I just stuck with one for this, and then you can change the type of loss function. And again, I use categorical cross entropy for my model. So future work, the next step to improve the model would be just to get every emotion up above 50%. I think that's an important step. And then you could throw in more emotions like the original competition was for. In the future, it would also be good to add automatic face detection and cropping, because the original intention I had of taking just normal images doesn't work. It didn't see a face, it got confused. So you need to be able to have that face detection so you could zoom into the face like all the test and train images were, and get your results that way. And here are my references, and that's it. Thank you for listening.